Okay, come down the home stretch of chapter 8. 8.6 is what's called exponential equations, and I really like this section because it suddenly gives you a lot of freedom to figure out problems in a pretty easy way. So, let us go right to an exponential equation and see what the heck I'm talking about here. So, given something like this, solve 8 to the x equals 32. At this point in your career, you should say, well, I'd like to solve that, but I need a common base. Hopefully that's what your brain would say. And so you might look at this for a minute, and your brain might try to trick you into thinking 8's a common base, but 8 to raise, there's no power, you raise 8 to 32. So going down, words, 2 cubed gets me to 8. And if you think about it, and 2 cubed is 8, and then I'm going to raise this up to x. 2 to the third power is 8. 8 times 2 is 16, and 16 times 2 gets us to 32. So I'm going to put a 5 right here. And power of a power we multiply, so this really is 2 to the 3x is equal to 2 to the 5th. And that then allows me to just set my exponents equal since my bases are equal, and so it turns out x is equal to 5/3. And hopefully that makes sense just as yet a little bit more review, because if I have 8 to the 5/3 power, remember the top is the power, the bottom is the root. Third root of 8 is 2, and 2 to the 5th power, sure enough, is 32. But now I want to introduce something new, and that is if x sub 1 equals x sub 2, then it is a fact that the log of x sub 1 has to be equal to the log of x sub 2. Now, one little thing that we do need to be clear about is these bases have to be equal. So for right now, I'm just going to put a little b in there. So what good is that? Well, this problem over here that we just did wasn't too painful with a little practice as far as getting a common base. But with this piece of information that I've just given you right here, all of a sudden, this amazing thing can happen, and I want to show you what you can do. Given a problem like this, you can say, well, I'm just going to go ahead and take the log of both sides. So I'm going to say log of 8 to the x then is equal to log 32. Now, what good does that do me? And once again, the reason I can do it is because I've been given a problem where these guys, they tell me they're equal, so then clearly I can then take the log of either side, and that should be equal. Using the rules that we've learned about logarithms, we can free this x from being in that exponent position by taking it in front. So x log 8 then is equal to log 32. And then I can finish the job by just dividing both sides by log 8. And this is where your trusty calculator is going to come in and save the day. So I'm going to put log 32 divided by log 8 into my calculator. So log 32, and you really got to be careful to make sure you close your parenthesis, divided by log 8, close my parenthesis, and you'll notice I get a yucky decimal, but I'm just going to go ahead and hit math, enter, enter, and out comes 5/3. And in this particular case, we could get the same base and solve this, but there's a lot of them, including the one that's coming your way next, that we can't get us the same base, so this is the technique that we need to use. So let me give you one of those. So, given something like this, solve 5 to the x equals 32. Round to nearest hundredth. So this is a case you can scratch your head for a while and you'll never find a common base. So now you just swoop in with this new technique and say, oh, that's easy. I'll just take the log of both sides. And by taking the log of both sides, suddenly I free that x from its exponent jail because it can float on down front here. Is equal to the log of 32. And now I just divide out my log 5 on both sides. And go to my calculator and take log 32 divided by log 5, which you can check on your own. And in the end, when we're rounding it to hundredths, we would get 2.15. Okay, so just some other variations on the theme. Given something like this, 5 times 7 to the x equals 1650. Find x, and we'll just say round to hundreds. Now, this is a place where there's potential danger, and what I would suggest is what I've suggested in other places, and that is when you're solving, get the thing that has the x all by itself, because that's the safest thing that you can do. So what do I do to do that? I divide this 5 out. So now I have 7 to the x equals 1650 divided by 5, which is 330. And I can just go about my business and solve this. But just to prove to you that not only log gets in the, with a common log gets in the game, I can, if I feel like it, use ln. It doesn't matter as long as I am consistent. So if you did it with log or ln, the same thing's going to happen. So by taking the ln of both sides, the same rules of logarithms apply. This just happens to be the natural log. And then I would divide both sides by ln of 7. And you can check this on your calculator. When I divide that out and round it, I get 2.98. So it's your choice. I'm going to show you an example here in a second, though, where using ln comes in very handy. Now, I do want to make a comment, and that is if you make a decision not to divide out that 5. So say instead you say, well, I'm going to take the ln of both sides. So you take the ln, let's make a bracket here, of 5 times 7 to the x equal to the ln of 1650. I need to remind you of something, and that is that you now have an ln of a product. So this really is the ln of 5 plus the ln of 7 to the x equals the ln of 1650. And so you have a little more work to do doing it this way, because then you'd have to subtract this ln of 5 out, and then you can do your x ln of 7 is equal to whatever this is equal to, and then do your division. So be careful. I highly recommend that you just isolate the thing with the x in it, and then it's much simpler, because if you do this, you really have created a case where you're taking the ln of a product, which when you break it apart ends up being the ln, or the sum of the ln of the factors. Okay, let's take a trip back into chapter 7. Say you put $100 into an account. With 5% interest per year. How many years until money doubles? Now, we've done problems like this, but we're a little bit limited, and I want to show you how what I just showed you how to do, so some of you are going to be able to solve this easier. So the equation that we used is something like this. Sometimes you see it as A is equal to A naught times 1 plus R to the T. Sometimes you'll see a P in this position. That just means principal, how much you start with. Okay, so what is the problem I'm trying to solve here? I want to know how long does it take for my money to double. So if I start with 100, I'm going to put 100 here. I'm going to come over here and I'm going to put in 1 plus my rate. 5% turned into a decimal is 0.05. And I'm trying to figure out what T is. Now I got to use my head over here to think about what is this amount I'm looking for. Well, it's going to be 200, because that's what happens when 100 doubles. You get to 200. So now what am I going to do? In the past, what we did is we had our y equals instead of putting this 200 in here, and we just scrolled through until we found what T gave us 200. But notice what we can do now with this new technique. If I divide this 100 out, I now have 1 plus 0.05 to the T is equal to 2. And now I can free this thing, what I'm looking for, by taking the log of both sides. And I'll use log once again. If I wanted, I could use ln. And I'm going to take the log of this side And what's the good news about that? In the end, the real good news is that I can now take this t and put it in the front. So now I have t log 1. Let me get rid of the plus 0.05 because 1 plus 0.05 is 1.05. And all I need to do now really is just to divide by this log 1.05 on both sides. And I'm not going to bring my calc up because you can check it on your own calculator. When you take the log of 2 divided by the log of 1.05, you get 14.2. Now I realize sometimes this is confusing, so technically it's going to double 2/10 of the year into after the 14th year, so we would actually have to say this would happen in the 15th year, since we are compounding annually, not anytime during the year. Okay, another example, and then just from one parting thought. So there's an element called fermium. It has a decay constant of negative 0.00866 grams per day. How many days for 10 grams to go to 7? Okay, now notice the word continuous is not in here at all. So the thing we need to realize about these elements is that they are decaying continuously. So the equation I want to use here is A is equal to A naught E to the RT. Okay, so I am starting with 10 grams of this stuff, and I'm trying to figure out how long it takes to go to 7. Remember, this is how much you start with. So then this is going to be e to the negative 0.00866 t. So first step I want to take is just get this thing by itself. So that means I want to divide this 10 out of here. So I'm going to go ahead and do that. So now I have e to the negative 0.00866 t. And over here I have 0.7. So now this is going to be an advertising announcement for using ln instead of logarithm, and for a reason. And the reason for that is that when I take, I'm just going to come over here, when I take the ln of e, something interesting happens, and you can use your calculator to determine that. But if you remember, the base for the natural log function is e. And we learned early on, a couple sections back, that whenever we take the ln of something and the base and the something are the same, it is always going to end up to be the number 1. So what does that do when I come back here? Well, if I take ln of 0.7, and over here I take the ln of e to the negative 0.00866 t, I'm going to go ahead and use my logarithm rules and bring this down into the front. So I have negative 0.00866 t ln of e. I can get to this place where I get to say, woohoo, ln of e, as I've shown you here, is equal to 1. And so now this problem has become even easier because I just have to divide out this kind of yucky thing. And that will help me arrive at my answer. And so in this particular case, when we divide that out, t is equal to 41.2. Now in this case, since it's happening continuously, it will be happening in 41 days. So this is a good tool to have in your toolbox. You could use just regular log, but then you won't have that ln of e situation where it turns to 1 and drops out and makes your life easier. Okay, last thing I want to teach you, and this is something you can memorize, but what I'm showing you here would allow you to figure this out if you ever needed to. Okay, now, hopefully you have the ability to figure out what this is equal to, because it's not anything too crazy, because A logarithm is an exponent, and so then hopefully at this point you would say, well, if this is a 2, a logarithm is exponent, what do I put above a 2 to get an 8? Oh, that's a 3. But right now, if you needed to use a calculator, you don't necessarily know what to do with it. So I would suggest that to just try to get to really figure out what do I need to do on my calculator is if I just temporarily, even though I know this is a 3, call this x, I could say I'm going to rewrite this in exponential form. A logarithm is an exponent, so I'm going to put an x here. The base is 2, and this is equal to 8. Now using what I just showed you in this section, I can take the log of both sides. So I'm going to go ahead and do that, which then allows me to free that exponent x. And then to solve for x, I'm going to divide by the log of 2. So let us determine if log 8 divided by log 2 is equal to 3. Here we go. Log 8 divided by log 2. Sure enough, it is equal to 3, as we expect. So, what is this, really? This is what's called the change of base formula. So basically, anytime, and this is going to help out more because in this case you can figure it out, but anytime you have the log of something with some base, and you want your calculator to help you figure it out, all you really need to do is take the log of A and divide it by the log of B. And that will allow you to figure out what it is. Personally, for me, I just remember I take the log of the thing kind of up top divided by the log of the thing below. And that will get you your answer. Okay, so there's some good stuff in this section. I hope you understood what I just said. Go to mathexcelforschools.com and do the quiz.